Across the oil and gas industry, burners are absolutely fundamental to operations, whether it's on your fired equipment, your flares, or your combustors. These systems are all going to serve a common purpose, which is this: allowing raw natural gas to flow into a controlled combustion environment to generate either heat, destroy hydrocarbons, or safely manage your excess gas. Before BTUs can be transferred, before emission is able to be controlled, and before production can safely continue, natural gas must be ignited reliably, repeatedly, and safely. Historically, the industry has relied on several methodologies to accomplish this task. Some have stood the test of time, others have represented very important steps in moving forward, while today new technologies are redefining what safe and reliable ignition can look like in the modern oil and gas operations. We're going to walk through the three primary ignition methodologies that are used in the field today: manual ignition, spark ignition, and Surefire's hot surface ignition, and why the evolution of ignition matters now more than ever. Today, manual ignition remains the most widely utilized practice for igniting burners on both fired equipment and combustion equipment such as flares or combustors. As a matter of fact, we believe over 70% of active applications still rely on manual ignition. Manual ignition requires the technician to introduce a flame or introduce combustion into flowing natural gas in order to create combustion. Now, this naturally, inherently, brings with it a number of safety factors that have to be considered. In order for a technician to relight a pilot safely, here's what has to happen. This technician must ensure that the main fuel train is turned off, ensuring that 8, 10, 12 pounds of natural gas is not free-flowing into the flame arrestor, thereby into the burner. At that point, a technician must take an apparatus, something similar to this right here, and light the end of this rag on fire, open up some sort of access port similar to this or a sight glass port, and physically introduce that flame into free-flowing natural gas on the pilot line. The technician at that point can then reintroduce the main gas slowly, ensuring that the main burner is now lit. This form of ignition has a number of issues. It's time consuming, it's frankly ineffective, and it bears with it a number of safety concerns that places technician in a potential opportunity for physical harm. We have seen things such as Roman candles. We have seen people throwing objects that are on fire in order to try and light a flare. This inherently is an unsafe practice. And although it's been accepted for a very long time, and although it is still the most commonly and widely used form of ignition, the problem is it's not safe, it's time consuming, it's not effective, and it leaves you and your team at risk. One of the big safety concerns with manual ignition is that a technician has to introduce combustion while there is free-flowing gas in the fire tube. Now, if you have a human error, or if you have a valve failure, and it is not caught before introducing combustion, what can occur is this vessel can be filled with natural gas. If a purging process is not successfully completed, what can happen is this vessel can be filled with natural gas. And when your technician goes to light off this burner, depending on the volume and the BTU rating of that vessel, that implosion can have a number of results. Result number one could simply be blowing out the flame arrestor, causing a loud implosion that may get the attention of surrounding locals. Physical harm: if we have combustion or fire backdraft out of our access port. If the implosion is large enough because of the volume of gas, we can have flame arrestors get sheared off, blowing them away from the fire tube. And if a technician is standing in a position like this when lighting off a pilot and there is gas free flowing, what can happen is that technician can be in harm's way and can be physically harmed by the implosion. We have heard stories and even been on location where we've heard implosion in nearby facilities. And every time it's the same story: manual ignition, free-flowing gas, safety practices not followed, mechanical failure, resulting in people being harmed, people being burned, and equipment being destroyed. And although this practice of manual ignition, again, is accepted, widely employed across the industry, it's not safe. It leaves your team, it leaves your equipment in harm's way, and there are certainly better ways to accomplish ignition. Another application that we'll discuss is flare applications. Most flare applications do not have any kind of control device on the vent lines going to these flares. And so if a pilot is extinguished, what then happens is that gas at very high volumes begins to free flow, free vent out of that flare. This requires a technician to go out to the location that is now filled with raw natural gas and utilize some kind of archaic method of lighting off that flare. As mentioned, we've seen Roman candles, we've seen manual devices such as rocks and glass bottles thrown over the top of a flare. We've seen bows and arrows. We've seen a number of ways that people are trying to create ignition. The problem with that is if there's gas at lower levels, gas at lower elevations, what could then happen is that when that gas is ignited, it creates a fireball, it creates an implosion, it creates a very unsafe environment, and your technician is now right in the middle of a space where there's free-flowing gas, combustion, implosion, and it puts him at a spot that's very unsafe. Spark ignition represented the industry's first real advancement in ignition and combustion technology, and it still is widely utilized in today's industry. It removed the requirement to have to manually ignite your flame, as we previously discussed, and it electrically creates a spark in those combustible environments and creates ignition in that fashion. This technology relies on a high voltage coil that generates up to 40,000 volts AC, and it creates a spark at the desired ignition point. But with that said, there is feedback that we have observed in person, as well as feedback from trusted clients and service partners in the industry in relationship to spark ignition. One of the downsides of spark ignition is that it's designed to carry energy through a ground to the sparking apparatus. If the insulation is damaged during installation or normal wear and tear, or there's equipment degradation, what can then occur is the voltage may be energized in an unintended conductive pathway. This can cause equipment frames, handrails, catwalks, or other metallic surfaces to become energized that personnel such as LDAR operators, pumpers, technicians may unintentionally come into contact with and thereby result in a shock of personnel. In a standard spark ignition BMS setup, the BMS is not always able to observe if the spark is occurring at the intended location. All the BMS is able to observe is there spark occurring? And so even if there's been equipment degradation, there can be sparking at an unintended physical location, and the BMS may not be aware of that environment and still produce spark, still allow gas to flow into the fire tube, possibly creating a very unsafe situation that may result in personnel or equipment harm. In addition to those safety factors, there are also some environmental and operational concerns as well. In applications such as combustors and flare applications, there can be elevated fail rates simply because the sparking apparatus has to be placed in a physical location near or up inside of the high heat environments. With spark apparatuses, again, it's designed to have energy travel down a ground. This causes this setup to be more vulnerable to high moisture environments. So in applications or environments rather, where there is a lot of snow, high humidity, a lot of rain, this particular setup can be more susceptible simply because water creates grounding, water creates shorting. And so in an application where energy has to travel down a ground, if you have moisture in certain situations, that spark's not going to reach this nozzle right here. It could potentially ground somewhere else back down the electrical conduit, creating again an unsafe situation. We all understand that if the sparking rod and the ground, if the distance between them is not maintained according to specifications, what will happen is, as the gap widens, the ability to create spark lessens. And eventually, if the gap widens too greatly, the spark is not able to bridge that gap. At that point in time, that will require a technician to go to location, remove the burner from operation, and readjust the spark gap. In certain situations, you may have to clean off this rod to ensure there's not corrosion and buildup that could prevent the conductivity between point A and point B. These are all factors that cause us maintenance when we're installing or operating spark ignition. Anytime there's elevated maintenance, anytime there's going to be a requirement for a technician to come out to the field to perform that maintenance, that is simply additional time, additional money that we are losing or that we are spending. Spark ignition remains a meaningful step forward by eliminating manual ignition. However, there are known limitations, especially in certain applications and in certain environments. Surefire's hot surface technology is a new evolution in the ignition technology world. It focuses and is designed around control, verification, and safety. A hot surface igniter operates on low voltage, 12-volt DC setup, and so it eliminates the potential of shock-related injury. The hot surface igniter has an internal resistance, so we can measure whether or not the igniter is able to achieve ignition in that moment in time. So we can ensure that before natural gas is released into the fire tube or into the combustor, that we're able to verify this igniter will in fact create combustion and we eliminate potential venting gas. If optimal ignition conditions do not exist with a hot surface igniter, our system will not allow valving to open. So again, we ensure that there is no venting. We ensure that your technicians are in a safe, controlled environment. With the hot surface technology, it enables us to create the pilotless ignition technology. And because we can control ignition and we can control the gas flow, we're able to safely and effectively eliminate our pilot and light the main burner in and of itself. Our hot surface igniter is also compatible with our FTLF series for flares and for combustor applications. Because again, our ability to control ignition and control combustion, we're able to position our igniter in a spot on these ignition units where they're not in harm's way like you would at times see with spark ignition. So it allows us to have longevity, it allows us to have reliability and reduced maintenance for your team. Other factors with hot surface ignition in relation to its advancements is with spark ignition, you have to have two things. You have to have a ground and you have to have an adequate spark gap between your sparking device and your ground. In these situations, if there is variances in your ground or variances in your spark gap, you're going to have a situation where you cannot create spark and now require a technician to go to location and perform maintenance. With a hot surface ignition, that's not a factor. There is no gap to maintain. There is no maintenance on the igniter that has to be done. There isn't cleaning of the ignition element. It simply operates in and of itself. It does not require consistent maintenance. It doesn't require creating a spark gap. So you don't have to open up the fire tube, you have to remove the burner and do cleaning and maintenance on that burner. That's not a factor with hot surface ignition. The other factor is because we're a low voltage 12-volt DC system, there isn't a ground to maintain. There isn't a grounding situation or electricity finding ground in our application. Because of hot surface ignition, we simply send 12 volts DC to our hot surface igniter and it creates enough temperature to safely, effectively create combustion. In that same train of thought, because of having to have ground with spark ignition in environments with high humidity or extreme moisture, freezing, snow, heavy rain, spark ignition can leave you vulnerable to downtime. So the benefit there of hot surface ignition is when moisture is in the area, when there's snow, when there's rain, our igniter isn't finding ground. Our voltage isn't finding ground. Our igniter continues to receive voltage and continues to create combustible environments. So the multiplicity of these factors creates a system where you have less downtime, less susceptibility, less parts to fail, and it creates a more reliable system. In addition to all of this, our hot surface igniter does not require a high voltage coil. The high voltage coil on spark systems creates a 40,000 volt AC supply that creates the spark. With the hot surface igniter, that's not a reality. There is no coil, there isn't 40,000 volts. It's all directly terminated to our circuit board with one less item to maintain, one less item to have to service. In our time here at Surefire, we've had the amazing opportunity of working with a number of clients, service groups, equipment manufacturers to implement our hot surface ignition technology into various applications. One application that comes to mind is a user out in the DJ Basin where they were consistently utilizing manual ignition to create their combustion for their pilot. One of the things that this client consistently said to us is their technicians were constantly having minor burns because of burn back or because of implosion coming back when they would introduce the manual combustion or manual ignition. What was informed to us is that following introducing the hot surface ignition technology into their application eliminated the consistent harm to their people, because all they're doing now is pressing a button and everything happens automatically and safely. It eliminated a lot of their maintenance, it reduced a lot of their downtime, and it created a lot of efficiencies. And so they went from 1 or 2 systems to a field-wide transfer from manual ignition to hot surface technology. In addition to that transition from manual ignition to hot surface, another user in the Anadarko Basin, they had spark ignition on a lot of their combustor applications. And some of the feedback that we received from them is when there was heavy rainstorms, they could systematically, through their PLC, watch the combustors go down, and they could tell where the rainstorm was by where the combustors were shutting down. And what was occurring is that the spark was sparking in the wrong spot because of the heavy introduction of rain in that region. And so what they decided to do is they decided to eliminate and remove some of the spark technology and introduce our hot surface igniters through our FTLF ignition series. What they immediately discovered is that during heavy rainfall, even when spark ignition would have some problems, the FTLF hot surface ignition technology, it continued to work nearly flawlessly because, again, we're not subject to moisture with hot surface. And so after that experiment that they did, they again elected to remove all of their spark ignition and go to hot surface ignition across the board. These are just 2 of the many stories I could tell you of people who were using manual ignition. They were familiar with that, they were used to it, but after trying hot surface, they found that that was a much better way and it eliminated a lot of issues for them. And the same can be said of spark ignition. Where there were susceptibilities with spark ignition, the hot surface igniter eliminates a lot of those susceptibilities, and so it creates a more efficient, more reliable system. Another testimonial that we can offer is a client in the Bakken Basin. They were consistently having problems because of their heavy snow, freezing during the winter, and they just could not keep their pilots lit. One of the main issues they were having was the freezing of orifices, as we mentioned in our last video, and issues with spark technology because of the heavy moisture. They made a switch over to the hot surface technology, which did 2 things for them. Number 1, it eliminated a lot of the issues with going to ground and not being able to create a spark inside of the fire tube, because again, hot surface does not require that technology. It can create the combustion environment in and of itself. The second thing it did, because we could use hot surface for pilotless technology, we were able to eliminate the pilot and go with pilotless, eliminating all the small orifices. The hot surface technology, it took an entire area that was struggling with downtime, struggling with maintenance, struggling with production levels, and it completely transformed their entire entire fields, and it's all because of the hot surface technology yielding way to the pilotless technology. One of the most telling indicators of a product's value from a manufacturing standpoint is the manufacturing warranty that comes along with that product. A typical spark igniter carries a 30 to 90 day warranty, while in contrast, the Surefire hot surface igniter assemblies carry with them a 24-month Surefire guarantee. A warranty is more than a policy. It's confidence in real-world performance, durability, and reliability. Manual ignition and spark ignition represent very important chapters in the evolution of this industry. But today's operating environments they demand more. They require greater safety margins, they improve reliability, they require reduced callouts, and they require verification of ignition control. So we invite you today to trial this technology, to see the difference of manual ignition versus spark ignition versus what hot surface ignition can provide you or your customers. Please give us a call today. Let us know how we can help.